What is weight?
Force of gravity on an object, F equals mg.
What is the Van Allen belt?
Donut-shaped regions of charged particles around Earth. Created by charged electrons and protons from solar wind and cosmic rays trapped by Earth's magnetic field.
What is a microwave oven?
Uses 2.4 GHz M waves to cook food.
Why are broadcast frequencies so limited?
Suppose the analog signal is a 440 Hz tone, the A above middle C on a piano. A typical AM transmitter would have a carrier wave frequency of 1 MHz, megahertz. The result is a signal with three different frequencies, 1 MHz, 1 MHz plus 440 Hz and 1 MHz, 440 Hz. Thus the total signal requires a set of frequencies 880 Hz wide. Sounds with a frequency of 4 kHz require a range of frequencies called the bandwidth, 8 kHz wide, just about the spacing between adjacent stations. FM stations, on the other hand, were developed to transmit sounds more faithfully. Which means that sounds up to 15 kHz must be accommodated. That means that the bandwidth of the broadcasts is 30 kHz wide. At the very high frequencies used by FM stations there is more bandwidth available and stations are spaced by 200 kHz. The electromagnetic spectrum has many other users. Police and firefighters usually use AM while aircraft, where noise reduction is important, use FM. Television stations used to use AM for the picture and FM for the sound. But as of June 12, 2009, they now all use digital signals. Other users are the military, marine ship-to-shore services, weather broadcasts, commercial mobile phones, the citizen band, and amateur radio operators. They all share the HF, VHF, UHF, and SHF bands.
What is a magnetic pole?
Region of magnetic strength at ends of magnets. Always come in north-south pairs.
Where are the best surfing beaches?
The best surfing beaches are located along the edges of oceans. When wind conditions have produced waves with large wavelengths. Another requirement of a good surfing beach is a gradual decrease in water depth.
Why are sunrises and sunsets often orange or red?
During the evening and early morning, when the sun is lower in the horizon, the light that the sun emits has to travel through more of the atmosphere to reach us than it does during midday. When the path through the atmosphere is shorter. Since the distance through the atmosphere is much larger for sunlight in the morning and evening than during midday, more of the shorter wavelengths of light are scattered out of the direct light from the sun. Thus the sun's color goes from yellow to orange and finally to red. Dust and water vapor in the atmosphere enhance this effect, making sunsets even redder.
What is meant by a law as opposed to a theory?
Laws summarize observations. They describe phenomena. A theory explains a large number of observations. Einstein's theory of gravity explains Newton's law of gravitation, which can be used to derive Kepler's three laws. A theory cannot become a law because they are essentially different things.
What is physics?
Physics is the study of the structure of the natural world. It seeks to explain natural phenomena in terms of a comprehensive theoretical structure in mathematical form. Physics depends on accurate instrumentation, precise measurements, and the expression of results in mathematical terms. It describes and explains the motion of objects that are subject to forces. Physics forms the basis of chemistry, biology, geology, and astronomy. Although these sciences involve the study of systems much more complex than those that physicists study, the fundamental aspects are all based on physics. Physics is also applied to engineering and technology. Therefore, a knowledge of physics is vital in today's technical world. For these reasons, physics is often called the fundamental science.
Do all relative velocities add?
Suppose you were riding on a spaceship moving at half the speed of light. If you were to point a laser in the direction the ship was moving, the person on the spaceship would be able to determine that the speed of the laser light was the speed of light, 300 million meters per second.
What is pressure of air?
At sea level about 101 kPa.
What is quantum chromodynamics, QCD?
the theory that describes the interactions between quarks and gluons.
Are these the same?
Mass defined as m equals fnit/a is called inertial mass. Mass defined as m equals f gravitation/g is called gravitational mass. Many physicists, starting with the Hungarian Baron von Eötvös, have done experiments to determine if the two kinds of mass are equal and if they are the same for all materials. Recent experiments have shown that if they are different, the difference is only 1 part in 1015. Furthermore, Einstein's general theory of relativity explains that they are identical, and calls this fact the principle of equivalence between gravitation and acceleration. In other words, the laws of physics in an accelerating reference frame or a gravitating frame are indistinguishable. You can't tell the difference between falling or being acted on by gravity.
What would happen to Earth if the Sun suddenly disappeared? How soon would Earth recognize that the Sun's gravitational field was gone?
It couldn't happen instantaneously, because Einstein's special theory of relativity says that no information can travel faster than the speed of light. So, it would take about 8 minutes before Earth would both experience the lack of sunlight and the lack of gravitational force. Many scientists now believe that gravity is the result of mass warping space-time. While the effects of gravity have long been studied and its laws defined, what the force of gravity actually is still is a matter of debate.
Where is the center of gravity of a person?
The center of gravity of a person depends on how that person's weight is distributed. The distribution is typically different in adult males and females. Males have more upper body mass while females have more mass in the hip region. A male's center of gravity is about 65% of his height, while that for a female is about 55%. Try this. Stand facing a wall with your toes against the wall. Now try to rise to stand on your toes.
What is the universal gravitational constant?
Proportionality between gravitational force between two objects and gmm/r2.
What is electrostatics?
Electrostatics is the study of the causes of the attractive and repulsive forces that result when objects made of two different materials are rubbed together. Electrostatics is the study of what is often called static electricity.
What is the history of electricity?
Prehistoric people valued and traded amber, a gem-like material that is petrified tree sap. Surely more than once a person would have rubbed amber on his or her fur clothing and noticed that fur was attracted to the stone. Perhaps she rubbed it hard enough to produce sparks. The Greek philosopher Thales of Miletus wrote about these effects around 600 BCE. But it wasn't until 1600 CE, some 2,200 years later, that William Gilbert, 1544 to 1603, an English physician, named this effect electricity after the Greek name for ember, electron. Gilbert showed that sulfur, wax, glass, and other materials behaved the same way as amber. He invented the first instrument to detect what we now call the electrical charge on objects called a versorium, a pointer that was attracted to charged object. Gilbert also discovered that a heated body lost its charge, and that moisture prevented the charging of all bodies. In 1729, the English scientist Stephen Gray, 1666 to 1736, determined that charge, or what he called the electric virtue, could be transmit over long distances by metals, objects that couldn't be charged.
What are quark generations?
Each generation has two quarks, up and down in first, strange and charm in second, top and bottom in third.
What is a diffraction?
Light or other wave bends around the edge of the hole, through a narrow slit, or around a small object.
What is pressure, P?
Force divided by area over which force is exerted.
Who was the first pilot to break the sound barrier?
On October 14, 1947, Chuck Yeager, 1923, broke the sound barrier in his Bell X-1 test plane, Glamorous Glennis. In order to reach the sound barrier, the X-1 was carried in the belly of a B-29 bomber to an altitude of 3,658 meters, 12,000 feet, where it was dropped. The X-1's rocket engine ignited and Yeager took the plane to an altitude of 13,106 meters, 43,000 feet. At this altitude, Yeager was able to break the sound barrier by traveling 660 miles per hour. The X-1 experienced a turbulent set of compression waves just before he broke past the barrier at Mach 1.05. Yeager kept the plane at this supersonic speed for a few moments before he cut off the rocket engine and headed back toward Earth.
What are the best ways to protect one's hearing at loud rock concerts?
The first protection against damage to the cilia is to increase the distance from your ears to the speakers. In plain English, the farther away one is from the speakers, the lower the intensity of the sound. By simply doubling the distance, the intensity becomes 1/4 of what it was originally. That can work in open areas where the sound can spread. But in arenas or halls the sound can reflect off the ceilings and walls and does not decrease with distance. The second method of protecting one's ears is to dampen the sound waves as they enter the ear. Many musicians, both rock and classical, to avoid gradual hearing loss, now use earplugs to decrease the amplitude of the wave entering the ear. The fluid in the cochlea transfers less energy to the cilia than if the listener were wearing no hearing protection.
How is surfing a lot like downhill skiing? How can they be similar?
Surfing is done on water, skiing on snow. The main similarity is that in both cases the athlete and board travel down a hill. In skiing, the hill is a mountain covered with snow, while in surfing the hill is the rising water of a breaking ocean wave. An ideal surfing wave has a large amplitude as it reaches an extremely gradual decrease in ocean depth. While the surfer moves down the wave, the water on the front edge of a crest continually rises underneath the surfer, allowing the surfer to ride down the wave without actually moving downward. Some of the best surfing is done on Waikiki Beach on Oahu in the summer and the north shores of Oahu and Kauai in Hawaii in the winter. In the continental United States the best surfing is in Southern California. The Pacific Ocean, famous for its long wavelengths and gradual decreasing depth beaches, has some of the best surfing in the world.
What is a sustainable energy source?
Primarily wind, water, and solar energy, ultimately receive their energy from the sun, and therefore will be available for billions of years.
What is the danger of short circuits in a home?
As described above, if there is only a tiny amount of resistance in a circuit, the current is very large and the wires get extremely hot. If, for example, the insulation on the wires in an appliance fails and the wires touch each other, the resistance drops and current rises. The wires, including those in the walls, can get hot enough to cause a fire. Household circuits are protected by fuses or circuit breakers. They are designed to open when current exceeds a predetermined limit. With the circuit now open, current stops and the wires will cool.
What is the interference of light?
We've explored wave interference before in the waves chapter. The key to the interference of light is that the two or more waves interfering must have the same wavelength and phase. While interference can be seen with ordinary light, interference is most easily seen using laser light. If light from a laser passes through two slits that are a small distance apart, the diffraction patterns from the two slits will overlap. When they do, a pattern of light and dark bands will be seen. The bright bands are where waves from the two slits are constructively interfering. The distance the light has traveled from the two slits will be equal, or they will differ by an integer number of wavelengths. The dark bands occur when the waves destructively interfere. In this case, the difference in distance light from the two slits will have traveled will be an odd number of half wavelengths. That is, 1/2, 3/2, 5/2, etc. Light can also interfere if it is reflected off two closely spaced interfaces, like the two surfaces of a soap bubble or oil film.
What is the index of refraction for light traveling through different media?
The following are some sample indices of refraction. The index of refraction, represented by n, is the ratio of the speed of light in a vacuum divided by the speed of light in the material. The larger the index of refraction, the greater the bending that takes place.
Does a musical tone have a single frequency?
It does not have a single frequency, but many. To understand why, consider a stringed instrument like a guitar, piano, or violin. The string can oscillate in response to it being plucked, hit, or bowed. Standing waves will be formed as they would be if you shook a rope back and forth. By shaking it at different frequencies, you can make it oscillate in several different modes. The lowest frequency results in nodes only at the ends. Twice this frequency produces nodes at the ends plus one in the middle. 3 times the lowest frequency give nodes at the ends plus 2 nodes at 1/3 and 2/3 its length. If you pluck, hit, or bow the string of a stringed instrument, you cause it to vibrate in many of those nodes at the same time, depending on the location you plucked it. The lowest frequency of oscillation is called the fundamental frequency. Plucking the string 1/4 from one end results in oscillations at 2, 3, 4, 6, and 7 times the fundamental frequency. The higher frequencies are called harmonics. For example, if the fundamental frequency were middle C, 256 Hz, then the second harmonic would have a frequency of 512 Hz, the third 728 Hz, the fourth 1024 Hz, etc. The sound made by the vibrating string is very weak. On acoustic stringed instruments, the strings pass over the bridge that transmits the oscillations to the top plate of the body of the instrument. Low-frequency sounds also excite oscillations in the ear and in the bottom plate of the guitar's body. Sounds from the oscillations of the air pass through the sound holes in the top plate into the surrounding air. The amplitude of the fundamental frequency is the largest. The relative amplitudes of the higher harmonics depend not only on the string, but the shape and size of the body of the instrument. Electric guitars will be discussed in the chapter on magnetism. The relative intensities of the higher harmonics depend on the instrument. The sound spectrum produced by the instrument is characterized by these relative amplitudes. The spectrum is also called the quality of sound, or the timbre. The sound quality also depends on how the sound starts and stops.
What is the first law of thermodynamics?
The first law of thermodynamics is a restatement of the conservation of energy. It says that the energy loss must equal the energy gain of a system. It relates the heat input and output, the work done on the system and the work the system does, and the change in internal energy, or temperature change. For example, the cylinder and moving piston of an automobile engine is heated by the burning of gasoline in the cylinder. The piston moves out, doing work, and heat is transferred to the coolant because of the higher temperature of the cylinder and piston. As long as the temperature of the cylinder and piston does not change, the heat input equals the work output plus the heat output. Energy isn't gained or lost, it just changes form. Another way to state the first law is that net heat input equals net work plus change in thermal energy. Note that heat can be either positive, heat input, or negative, heat output. Work can also be positive, work done by the system, or negative, work done on the system. Thermal energy can also go up or down.
What is the first law of thermodynamics?
A restatement of the conservation of energy, net heat input equals net work plus change in thermal energy.
How else is friction useful in accelerating things? How do you walk or run?
Your feet are also interacting with the ground. As long as there is sufficient friction, when you push your feet backwards, the ground pushes you forward.
What is the Kelvin scale?
The Kelvin temperature scale, developed by William Thomson, Lord Kelvin. 1824 to 1907, in 1848, is widely used by scientists throughout the world. Absolute zero is the temperature at which thermal energy is at a minimum. Each division in the Kelvin scale, called a Kelvin, K, is equal to a degree on the Celsius scale, but the difference is where zero is. In the Celsius scale, 0 degrees is the freezing point of water, while in the Kelvin scale, the 0 point is at absolute zero. Therefore, 0 degrees Kelvin is equal to minus 273.15 degrees Celsius, 0 degrees Celsius is equal to 273.15 kelvins. The Kelvin scale is used for very low or very high temperatures when water is not involved.
Do rolling objects experience contact friction?
Whether it is a bowling ball rolling down the alley or a wheel rolling on the road, there is no sliding between the ball or wheel and the flat surface, so there can be no contact friction.
What is an image, real?
Light rays do converge. Can be projected on a screen.
What is a decibel?
A decibel, dB, is the internationally adopted unit for the relative intensity of sound. The sound intensity of 0 decibel is the threshold of human hearing. 1016 Watt/cm2. This corresponds to a pressure of 2 x 10⁵ Newton/m2 or 2 billionths of atmospheric pressure. The ear is extremely sensitive. The decibel scale is a logarithmic scale, meaning for every 10 decibels, the intensity is increased by a factor of 10. For example, a change from 30 decibels to 40 decibels means the sound will be 10 times more intense. A change from 30 decibels to 50 decibels would mean the new sound would be 100 times more intense. The following chart shows a typical sound environment, how many times louder those levels are than the threshold of human hearing, and the relative intensity of that sound compared to the threshold of hearing.
Is Earth's atmosphere transparent to infrared and ultraviolet radiation as well as to light?
Oxygen and nitrogen, the two principal components of our atmosphere, are transparent to light and to most infrared, IR, and ultraviolet, UV, wavelengths. Infrared from the sun helps warm Earth and long wavelength. Ultraviolet is necessary for our bodies to produce vitamin D. Too much UV, however, harms the skin, and may damage our DNA. A high-altitude layer of ozone in our atmosphere protects Earth from all but a small fraction of the UV radiated by the sun. Ozone molecules have 3 oxygen atoms as opposed to the 2 in oxygen gas. In recent years, large and growing holes in this protective layer have developed due to the emission of chlorofluorocarbon. CFC, molecules from things such as escaped gases from refrigerants and aerosol propellants. Because these gases are no longer being manufactured and existing stocks are gradually being replaced, the growth of the holes should eventually stop. Carbon dioxide, methane, and water vapor are transparent to light and short-wavelength infrared radiation, but are opaque to the long-wavelength infrared emitted by warm objects. They are called greenhouse gases. These gases pass the IR rays that warm Earth but reflect the IR rays emitted by the warm Earth back to the ground. Thus they act as an insulating blanket for Earth. Over the past decades, the amount of carbon dioxide in the atmosphere has increased dramatically. Much of the increase is due to human activity. This increase is likely to lead to a warmer Earth that could shift weather patterns, disrupting food production, causing shifts in locations of forests and animals, and, by melting polar ice, increasing sea levels. The degree of warming and its impact on Earth and humans is under intensive investigation.
What is Coulomb's law?
Coulomb's law describes the strength of the electrical force between two charged objects. The formula is F equals K, Chi Q2/R2, where K is a constant equal to 9.0 x 109 nm2/C2, Newton meters squared per coulombs squared. The charges Q1 and Q2, measured in coulombs, represent the charges on the objects that cause the force F, measured in newtons. Finally, r is the distance between the centers of the two charged objects. A negative force is an attractive force, while a positive force is repulsive.
What is the zeroth law of thermodynamics?
If objects A and B are in equilibrium and B and C are in equilibrium, then A and C are also in equilibrium.
What is Maxwell's equations?
Four equations that describe the nature of electric and magnetic fields.
How do you use specific heat capacity information?
Specific heat capacity is the energy per kilogram per change in temperature. So, to find the amount of energy needed to heat something, you need to know the material, its mass, and the change in temperature desired. For example, if you wanted to increase the temperature of 2 liters, 2 kilograms of water from room temperature, 20 degrees Celsius, to the boiling point, 100 degrees Celsius, you need to multiply the specific heat capacity of water. 4186 J/kg degree C, by 2 kilograms and by 80 degrees Celsius to obtain 669,760 J, or about 670 kJ. Suppose that the water is placed in an aluminium pan with a mass of 300 G, 0.3 kilograms.
How does the gravitational force cause the motion of planets?
In antiquity, the planets, the name comes from the fact that they seem to wander across the sky, were assumed to have circular orbits. In order to account for the observations, their motion was thought to involve circles attached to other circles. In between 1600 and 1605, Johannes Kepler, 1571 to 1630, made careful studies of the observations of Mars made by Tycho Brahe, 1546 to 1601. He found that a circular path required Tycho's observations to be wrong by 2 minutes of arcade. 4 times the apparent size of the Moon, but he knew that Tycho's work was better than that. After some 40 failed attempts, he finally discovered that the orbit could be described as an ellipse. We now know an ellipse fits the orbits of all planets, comets, and other bodies about the Sun, as well as satellites about planets. The shape of the orbit is called Kepler's first law. An ellipse is not a circle. So the gravitational force of the Sun is not always perpendicular to the motion. Therefore, the planet's speed changes as it moves around its orbit. Kepler's second law says that in equal times planets sweep out equal areas. Thus, if the planet is closer to the Sun, it will move faster than it does when it is farther away. Kepler's third law was actually obtained in 1595 and was based primarily on philosophical and theological arguments. It stated that the relative sizes of the orbits of planets around the Sun could be obtained by nesting the 5 Platonic solids: the cube, tetrahedron, dodecahedron, icosahedron, and octahedron. The planets' orbits were in the spheres that circumscribed each solid. Today we state this law as the square of the period of the planet is proportional to the cube of the radius of the orbit. The proportionality constant depends on the mass of the object about which the orbit occurs and the universal gravitational constant. The law summarizes 2 of the properties of orbits of planets or satellites about a central star or planet.
How far away was that lightning?
When a lightning bolt goes from cloud to cloud or cloud to ground, it suddenly heats the air through which it passes. This sudden increase in temperature causes thunder that occurs at the same time as the lightning. Although it takes virtually no time to see the lightning, depending upon the observer's distance from the lightning, it can take quite a while to hear the thunder. The speed of sound at room temperature is about 1,100 feet per second. A mile is 5,280 feet, so it takes about 5 seconds for sound to travel 1 mile. So, to determine how far away lightning has struck, when you see the lightning, count the number of seconds it takes before hearing thunder. Divide the number of seconds between the lightning and thunder by 5. To determine how many miles away the thunder and lightning occurred. For example, if you see a flash of lightning and approximately 10 seconds later you hear the thunder, divide the 10 seconds by the 5 seconds per mile to find that the lightning occurred 2 miles away.
What is mass energy?
Potential energy, the result of the mass of an object first postulated by Einstein.
What is a VAD de Graaff generator?
Device using static electricity to produce very large potential differences.
What is a watt?
A watt is the unit of power, or the rate of energy transfer. Light bulbs, toasters, hair dryers, televisions, and other electrical appliances are rated by the power they use. In the context of electricity, the watt is the unit for electrical power and is often found on light bulbs and other devices used in electrical circuits. The formula to find the power used is P equals I x VT, power equals current times voltage.
How can energy be transferred?
Any energy transfer involves a source, whose energy is reduced. A means of transferring the energy, and an energy receiver, whose energy is increased. It's convenient to use a diagram to keep track of the source, the transfer, and the receiver, see pages 61 to 62. For example, if a moving pool ball collides with another ball, it can transfer all or part of its kinetic energy to the other ball. Transfer of energy by this kind of mechanical interaction is called work. The moving ball does work on the stationary ball and its kinetic energy is reduced. The kinetic energy of the stationary ball is increased by the work done on it. When a slingshot does work on the stone, its stored elastic energy decreases and the kinetic energy of the stone increases. When you throw a ball, your stored chemical energy is reduced. Work is done on the ball, and the ball's kinetic energy is increased. Other methods of transferring energy that do not involve work will be discussed later.
What is specific heat capacity?
Amount of energy needed to increase the temperature of 1 kilogram of a substance by 1 degree Celsius.
What contributions did Aristotle make?
Aristotle was a Greek philosopher and scientist who lived for 62 years in the 4th century BCE. He was a student of Plato and an accomplished scholar in the fields of biology, physics, mathematics, philosophy, astronomy, politics, religion, and education. In physics, Aristotle believed that there were 5 elements: earth, air, fire, water, and the 5th element, the quintessence, called ether, out of which all objects in the heavens were made. He believed that these elements moved in order to seek out each other. He stated that if all forces were removed, an object could not move. Thus motion, even with no change in speed or direction, requires a continuous force. He believed that motion was the result of the interaction between an object and the medium through which it moves. Through the 3rd century BCE and later, experimental achievements in physics were made in such cities as Alexandria and other major cities throughout the Mediterranean. Archimedes, c. 287–c. 212 BCE, measured the density of objects by measuring their displacement of water. Aristarchus of Samos is credited with measuring the ratio of the distances from Earth to the Sun and to the Moon, and espoused a sun-centered system. Eratosthenes determined the circumference of Earth by using shadows and trigonometry. Hipparchus discovered the precession of the equinoxes. And finally, in the 1st century CE, Claudius Ptolemy proposed an order of planetary scientists disappeared. In the 800s, the rulers of the Islamic Caliphate collected as many of the remaining books as they could and had them translated into Arabic. Between then and about 1200, a number of scientists in the Islamic countries demonstrated the errors in Aristotelian physics. Included in this group is Al-Hazan, Ibn Shakir, Al-Biruni, Al-Hazini, and Al-Baghdadi. Mainly members of the House of Wisdom in Baghdad. They foreshadowed the ideas that Copernicus, Galileo, and Newton would later develop more fully. Despite these challenges, Aristotle's physics was dominant in European universities into the late 17th century.
What is an audion?
A vacuum tube amplifier invented in 1906 by Lee de Forest.
Why is it important to beware of excess electrostatic buildup when working with computer equipment?
If you have ever installed a circuit board or card into a computer, the product probably was shipped in a static-free bag. This bag is designed to keep all excess static charge outside the bag. Many electronic circuits are sensitive to the electrostatic buildup and can be damaged if such a charge accumulates on sections of the circuit.
What is a precession?
The rotation of the axis of rotation of a rotating object due to a torque on the object.
How then does a one-way mirror work?
First, the mirror isn't totally reflecting. It transmits half the light and reflects the other half. The second requirement has to do with lighting. It is imperative that the observation room remain dark, because if a lamp were turned on, some of that light would pass through into the interrogation room as well.
What is an isotrope?
Nuclei with the same number of protons but different numbers of neutrons.
How can that be useful?
It's because the distance moved, output distance, is larger than what you move, input distance. And, therefore, the output speed is also greater. A baseball bat, tennis racket, and golf club can be considered simple machines in which high speed of the end of the implement is desired.
Who developed the Celsius scale?
On the Celsius scale, the freezing point of water is 0 degrees and the boiling point is 100 degrees. The Celsius scale is named after a person whose life work was dedicated to astronomy. Anders Celsius, 1701 to 1744, a Swedish astronomer, spent most of his life studying the heavens. Before developing the Celsius temperature scale in 1742, he published a book in 1733 documenting the details of hundreds of observations he had made of the aurora borealis, or northern lights. Celsius died in 1744 at the age of 43.
What is thermodynamics and statistical mechanics?
Studies how temperature affects matter and how heat is transferred. Thermodynamics deals with macroscopic objects. Statistical mechanics concerns the atomic and molecular motions of larger numbers of particles.
What is additive color mixing?
Combining blue, green, and red light to form other colors.
What is brass?
An alloy that is typically 80% to 90% copper with zinc.
What is an open circuit?
A circuit is a closed loop through which electric charges can flow. If the loop is opened, then it is called an open circuit and charges no longer flow. A switch is commonly used to open and close a circuit. If a wire breaks, the connection between the wire and another part of the circuit fails. Or if a lamp burns out, its filament breaks, then the circuit is opened and there is no current.
Who invented the first thermometer?
Although Galileo, 1564 to 1642, is credited with developing the first thermometer in 1592, his thermometer was open to the atmosphere. So it measured a combination of temperature and atmospheric pressure. It was not until 1713 that Daniel Gabriel Fahrenheit 1686 to 1736, developed the first closed-tube mercury thermometer. Combined with the temperature scale he defined the following year. Fahrenheit made a significant contribution to science.
Are pulleys really simple machines?
A fixed, or unmovable, single pulley can be considered a wheel and axle where both have the same radius. The mechanical advantage is one, but the pulley changes the direction of the force. If the pulley is allowed to move and the output force is exerted by the axle of the pulley, then the input force is shared by the two ends of the rope. If you fasten one end and pull up on the other, then you achieve a mechanical advantage of 2. A combination of fixed and movable pulleys is called a block and tackle. Archimedes is said to have pulled a fully loaded ship using a block and tackle. Energy loss in a block and tackle comes from friction between the axle and its holder, as well as the stretching of the rope and rolling friction between the rope and pulley.
What kind of forces can you exert on an object?
Hold a book in your two hands. What kind of forces can you exert on it? You could pull on the book to try to make it longer, or you push it to try to make it shorter. The name for the force on the book that pulls on it is a tension force, while the name for the force that pushes on it is a compressive force. You could also try to twist it, applying what is called a torsional force. Finally, place one hand on the front cover and the other hand on the back cover. Now push one hand to the right and the other to the left. This places a shear force on the book. Tension forces are common. If you hang from a chin-up bar, Your arms experience a tension force. Pulling on a rope, wire, or cable also exerts tension on them. Materials experiencing tension will stretch some more and some less. Materials that stretch easily are called pliant, those that do not are called rigid. Scientists have measured the response of materials to tension and compression. The ratio of the applied pressure, called stress, to the change in length divided by the original length, called strain, is called Young's modulus. Its value varies from 10 Gn/m to 10 billion newtons per square meter. In wood to 200 Gn/m2 in steel and cast iron. That means that for an equal force on it, steel will stretch, or compress, 1/20th as much as wood. If you would hang a 120 kilogram, 264 pound, ball from a 6 meter, 19.7 feet. long steel cable 2.5 millimeters, 0.9 inches, in diameter, it would stretch 7 millimeters, 0.3 inches. In the case of the cable above, when you remove the weight, the cable will return to its original length. It is called an elastic material. If you exert a much larger force, the cable will not return to its original length. This is called the plastic region. At some point it will break. The force that breaks it is called the tensile strength. For steel, the tensile strength is 1 Gn/m2. Thus for cable in the example above, it would take a hanging mass of 500 kilograms, 1,100 pounds, to break the cable. Young's modulus also describes the change in length of an object when a compressive force is exerted on it. When you stand, you exert a compressive force on your leg bones and they will shrink somewhat in length. But a 70 kilogram, 154 pound, person standing on one leg will compress it by only 0.01% of its length. The Young's modulus for cartilage, the material between the bones in all parts of your body, is 1/10,000th as large as that of bone. So putting the weight of a 70 kilogram, 154 pound mass on a piece of cartilage with same area as the femur in your leg would compress it by 10% of its original thickness. For compressive forces there is a compressive strength. But, many materials will buckle if too great a compressive force is placed on it. Brittle materials will, on the other hand, break. The compressive and tensile strength of bones is almost exactly the same.
What is the difference between a kilowatt and a kilowatt hour?
A kilowatt, 1000 watts, is the unit used to describe the power. The rate at which the energy is being converted. Energy is the power multiplied by the time it is used, in this case hours. Therefore a kilowatt hour, the product of power and time, is a unit of energy. The utility company charges you for the number of kilowatt hours of electricity you use in a month. For example, a 100-watt light bulb uses 100 watts, or 0.1 kilowatt, of power. if that light bulb were left on for an entire month. The energy that the bulb consumed would be 0.1 kilowatts x 24 hours/days x 30 days/month, which equals 72 kilowatt hours/month. If the energy cost is 12 cents per kilowatt hour, the bill for that one light bulb would be $8.64 per month. Replacing the 100-watt incandescent lamp with a 23-watt compact fluorescent lamp that is equally bright would cost only $1.98 per month. An LED lamp equally bright has a power rating of only 13 watts, and therefore would cost $1.12 to light.
Why would you need to know the time this accurately?
Businesses that use computers in many parts of the world can synchronize their computers so that the precise time that transactions occurred are known. GPS also provides navigation information. Hikers use GPS to replace maps, which are often outdated, compasses, and lists of landmarks. Automobile and truck drivers use GPS to replace paper maps and to find local businesses, such as banks, restaurants, and gas stations. Farmers use GPS to map precise locations in their fields. Not only does this information improve planting, it can be used to mark the locations of areas that need additional insect control chemicals or fertilizers. Engineers are now working on GPS systems to improve the flow of automobile traffic and reduce crashes. Each car would have a GPS receiver that would then broadcast its position. This information could be used to change red traffic lights to green if there were no opposing traffic. If two cars were equipped this way, the system could determine the distance between them and their relative speeds. If they were on a collision course, the system would apply the brakes to avoid a crash.
What is the difference between speed and velocity?
Just as you can add direction to a change in position and end up with displacement, you can also specify the direction of motion. The combination of speed with direction is called velocity. Velocity is the displacement divided by the time required to make the change, or the time rate of change of displacement. Velocity is a vector quantity, like displacement. You might walk at 4 miles per hour north, or a balloon might move at 5 feet per second up. If you assign the variable x to represent north/south, y to east/west, and z to up/down position, then both the change in position and speed would be positive for movement to the north, east, or up. Your walking velocity would be plus 4x mph. The balloons would be plus 5z. Foot/s average speed is almost always more useful than average velocity. For example, in a NASCAR race, the starting and finish lines are in the same position. So, no matter how fast the cars go, their average velocity is zero because the beginning and ending positions are the same. Instantaneous velocity, however, is more useful than instantaneous speed, as will be shown shortly.
What is an electric field?
As discussed before, a gravitational field surrounds Earth or any object with mass. Another object with mass that is placed in this field will experience a gravitational force on it. In the same manner, an electric field surrounds a charged object. Another charged object placed in that field will experience a force. If a positive force creates the field, then the force caused by the field on a negative force will be toward the source of the field. A positive charge will experience a force away from the source. The English physicist Michael Faraday, 1791 to 1867, was the first to use the concept of a field to describe the electrostatic force.
What was the first concert hall to be designed by an acoustical physicist?
Boston Symphony Hall, designed by physicist Wallace Clement Sabina, 1868 to 1919. Is the first concert hall designed specifically to enhance the sound of an orchestra. Sabina, who designed the hall in the late 1890s, discovered the relationship between sound intensity, absorption, and reverberation time. Sound reflections can either enhance or ruin a sound. Sabina discovered that having strong reflections immediately after a sound was produced would enhance the acoustics. But if sound was reflected midway between the source and the listener, it would detract from the acoustics because the time of travel would be significantly different. Sabine's Boston Symphony Hall, built in 1900, established an excellent reputation for sound quality. Mostly due to the choices of sound absorption materials as well as the strategic placement of reflecting material. The goal was to use the sound reflecting materials, high % reflection ratios, to create strong initial reflections, while using sound absorbing materials, low % reflection ratios, to absorb most of the energy from sound that would ordinarily reflect off of the high ceiling and the side walls in the rear of the hall. In 1973, Mr. Avery Fisher contributed over $10 million to support a complete reconstruction of the hall, and the hall is now named after him. The changes improved the acoustics, but the large stage reduced the loudness of bass sounds and the initial reflections were still too strong. Curved surfaces on the stage made of extremely tight grain maple would have improved bass problem, and reflectors consisting of 30,000 dowel rods were installed on the side walls. Except for classical music concerts and opera, most performances use electronic amplification. Loudspeakers can be located throughout the hall, and their response to different frequencies can be adjusted to compensate for shortcomings in the hall. The signal to speakers far from the stage can be delayed, so sound from all speakers arrives at the same time. Further, These changes can be adjusted so that the hall has the best acoustics for any type of use.
What is a synthesizer?
Electronic device that generates, alters, and combines a variety of waveforms to produce complex sounds.
What is a solar eclipse?
Occurs when the moon casts its shadow on Earth. The moon must be directly between the sun and Earth.
Does the United States use SI?
Although the American scientific community uses the SI system of measurement, the general American public still uses the traditional English system of measurement. In an effort to change over to the metric system, the United States government instituted the Metric Conversion Act in 1975. Although the act committed the United States to increasing the use of the metric system, it was on a voluntary basis only. The Omnibus Trade and Competitiveness Act of 1988 required all federal agencies to adopt the metric system in their business dealings by 1992. Therefore, all companies that held government contracts had to convert to metric. Although approximately 60% of American corporations manufacture metric products, the English system still is the predominant system of measurement in the United States.
What is a watt? W.
Unit of power. 1 watt is 1 joule, J, per second, S.
What happens if more than one force acts on an object?
You can explore this question with your toy car or ball. Try exerting two forces, like two finger taps in the same direction. You can see that the car or ball moves faster. The forces add.
What is a quark?
Particles that make up protons and neutrons and other short-lived particles. Fractionally charged, that is, their charges are either 2/3 or 1/3 the charge of the proton and are called up and down respectively.
What is a newton? N.
Unit of measure of force. In the English system, force is measured in pounds, lbs.